Welcome back. In this physics tutorial, we're going to look at Snell's law. And Snell's law has to do with finding the angle of refraction. So we have a nice picture here. This picture shows a wave or a light beam coming from point P and comes down here. It strikes this medium change. So in the top half, we have one medium, and in the bottom half, we have a second medium. So right here at point O, it's changing mediums. And in this situation, it is slowing down. It's changing mediums, the wave is slowing down, and it causes it to refract or to bend at this angle. The angle that it's bending at is this angle here, theta 2. And our original theta 1, both of these are measured from the normal, which is the line that's perpendicular to the surface itself. So we also have these other letters over here. We have N1 and N2. And N1 and N2 are basically they're constants that are a property of the material. So those are numbers we can look up. The one that the system is based off of is air, and N for air equals 1. So that one you should know. The rest of them, they will be given. And we have these two velocities, v1 and v2. And these two velocities are the velocity of the wave traveling in that medium. So really, if I erase all of this, so really, to help you keep everything straight, just think of it as this whole top medium. So we have our line here, our different mediums. And the top, we'll call medium number 1. And the bottom, we have medium number 2. And so you can kind of see in medium number 1 in the top half, we have theta 1, N1, and V1. And in the bottom half, we have theta 2, N2, and V2. So given those, we can, let's look at our equation. So our equation is, it's a little blurry, but it's sine theta 1 divided by sine of theta 2 equals V1 divided by V2, which equals N2 divided by N1. And we're never going to use all three of these sides. I mean, it looks kind of strange with two equal signs there. So usually we're going to block one out. So if the problem gives us velocities and angles, well, then we would just ignore this part and just focus on the parts that have the angles and the velocities. If the problem gives us the index of refraction, our n values, and the angles, well, we wouldn't have that part, and it would just be sine theta 1 over sine theta 2 equals N2 over N1. So let's look at a couple of examples. So example 1. An earthquake P wave passes across the boundary in rock, where its velocity increases from 6.5 kilometers per second to 8 kilometers per second. If it strikes the boundary at an incident angle of 30 degrees, what is the angle of refraction? So we have our equation, and I'm going to draw a picture, because I think pictures help. So there's our boundary. We have our normal, which is perpendicular to our boundary. And we have the earthquake P wave. It's coming in at a 30-degree angle. So it's coming here at a 30-degree angle. And we're trying to figure out this angle that it refracts. And because it's in, we'll label this one medium 1, and this is medium 2. So because this is medium 2, this is our theta 2. And we know the velocity. So the velocity of, in medium 1, in the first half, the velocity is 6.5 kilometers per second. And in the medium 2, the velocity is 8 kilometers per second. And let's put our kilometers per second. Always good to have units. So that's our picture. And so now let's put it into our equation. We could see in this example, we do not have the index of refraction. We don't have these n values. So all of this, we're just going to ignore that because we don't have it. So basically, we have sine of theta 1. Theta 1 is in the top half. That is sine of 30. Divided by sine of theta 2, which we don't know. That's going to equal V1. V1 is 6.5. That's in the top. And V2, that's the velocity in the bottom. That is 8. And now we're just going to solve for theta. So to solve for theta, I'm going to cross multiply. So I'm going to multiply these together. And I'm going to multiply these together. So I get 8 sine 30 equals 6.5 sine of theta 2. I know sine of 30 is a half, so 8 times a half is 4. And looking great. I'm going to divide both sides by 6.5. And so I have sine of theta equals 4 divided by 6.5, which is 0.62. And now this last piece, I'm going to take the inverse sine of both sides. So the inverse sine will cancel the sine, and I get my angle. And on this side, I have the inverse sine of 0.62. And I get 38 degrees. So it's really not that complicated at all. Pretty simple stuff, nothing too confusing. Let's look at one more example. I want to look at one more example that has this index of refraction as opposed to the velocity. So a beam of light in air is incident at an angle of 35 degrees to the surface of a rectangular block of clear plastic. What is the angle of refraction? So once again, we have our equation. And let's draw a picture. Like I said, pictures I think help. So we have our light wave coming in at an angle of 35 degrees. We're trying to find the angle of refraction again. So we're trying to find this. This is our theta 2, because once again, this is medium number 2 and medium number 1. And we know the n's. So for N1, this is air. N1 is 1 for air. And N2, this is our plastic. It is 1.75. So given that, we can find what we need to find. So we have sine of 35 over sine of theta equals, this is one tricky part. You'll see we have sine theta 1 equals V1 equals N2. So there's a 1 on the top, a 1 on the top, and then a 2 on the top. So don't get confused with that. But you can see that we don't have a velocity. So this whole term is just going to go away. So we did our sines, and now we just have our n's. N2 is 1.75. Make sure you put the 2 on the top, because that's what the equation says right there. And it's over 1. So in this situation, I will cross multiply again. So I have 1.75 sine of theta equals sine of 35. And so sine of 35 is 0.57 equals 1.75 sine of theta. And I'm going to divide both sides by 1.75. Get rid of that highlight. And so sine theta equals what do we got? 0.33. And then to find this, I'm going to kill the signs. I'm going to take the inverse sine of that and the inverse sine of that. The signs go away. I'm left with theta equals, and the inverse sine of that angle is 19.13 degrees. All right, and there you have it. Not too hard, not too shabby. Thanks for joining, and hope you understand this. If not, make sure you come by and ask me some questions soon. Thank you.